Hey guys, Killboy here. I've had a few people asking about my helicopter RC drone setup. Figure rather than explaining it, typing it out every time, I just do a video and kind of cover some of the common questions people are asking. Now some of this stuff, you know, I know it looks a little more advanced than probably what most people are looking at when they get into this, but it still has a lot of features that the entry-level, well, maybe above entry-level quads have, as far as like GPS lock and all these things I'll kind of cover, but it has also some more advanced stuff like autonomous programmable flight. I'll get into that. But basically this is a 6-rotor helicopter, hexacopter. The reason I upgraded from a 4-rotor to a 6-rotor is it gives you a little bit more redundancy. If there's a prop failure or a motor failure or a speed controller failure, each motor has its own electronic speed controller. And if any of those things fail, it'll still fly, even if you lose 1 or 2 or maybe even 3, I'm not sure, but as long as they're not on the same arm. But with a quad rotor, if you lose 1, it's pretty much going down uncontrollably. The common questions: how long does it fly? With the current setup, which is pretty much maxed out with everything you could possibly want on it, it flies about 10, 12, 13 minutes. Didn't have quite so much stuff on it, it'd probably fly for 15, 20 minutes. I'll go into some of the pieces that it came with and that I added to it. The most significant piece, and for those of you who've been following me, you know I had this on the last one, is the stabilizing gimbal for the GoPro. So that has a gyroscopic sensor built into it, and when you turn it on, it automatically levels the GoPro. You can adjust the default angle, if you can see this. So I can control it with the controller, the transmitter, and sort of set the angle that it's going to hold until you rotate the knob and change it. That's something that you kind of need possibly a more advanced controller than what might come with some of those entry-level quads out of the box. They don't always give you the ability to control the angle. The other thing that I have that's a little more advanced maybe than a lot of them come with is a direct feed. So you can see on the, I can't get my hand in front of it, but anyway, you can see on the LCD screen there, it has a live feed from the GoPro, so I can see, you know, what I'm getting as far as composition and everything. I went without that with the original quad that I started off with before this one, and it's not too hard. With the GoPro, it's so wide angle, it's almost 180 degree field of view, 170 degrees. So pretty much if you have the quad pointed in the right direction, and you usually have the camera, you know, mounted in a fixed manner that you know roughly, you know, how it's tilted, then it's not that hard to get whatever you want to get in the frame. Everything looks a little farther away when you shoot wide angle, and you can adjust these new GoPros to shoot full wide or medium or narrow. Narrow is still 90 degrees, it's not real narrow, and it's just cropping in on the original video feed. I don't know, other questions like why did I pick this model, or which one is it? This is a 3DRobotics.com 3D Robotics Y6 model. It's called and I don't have the arms fully locked out here. You can't, I've got them kind of where to fold because I was going to show you that, but basically they will normally lock out in a Y pattern so that they're all exactly the same distance apart, 120 degrees between each pair set of arms. The reason I like this one over a traditional 6-armed 6-rotor hexacopter, this one gives you a better view for the camera, and since that's all I was interested in doing anyway, I like this design better. The 6-armed traditional hexacopters, they have arms that stick out in the front and the back and everything, and so with a stabilized camera like this, I'm going to point this up so you can get a better idea. So with a stabilized camera like this, when you pitch the craft forwards and backwards to move, you know, in the air, the camera stays level. So effectively, if you pitch the craft forward, the camera points up. And if you have a bunch of arms sticking out over the camera, when you do that, they drop down into the shot and they end up getting in the top of your shot. With this setup, the props are way out to the side, so they tend to stay out of the shot. I get just a little bit of the edge of the prop sometimes if I really throw it forward and the camera's pointed all the way up instead of, you know, one of the lower angles. But I really thought that was a nice feature of it. Now, it is a little bit less efficient because the way these work, one rotor spins one way, one rotor spins the other way, but the bottom rotor is in the dirty air of the top rotor. So it's not as efficient. It would be more efficient if it had its own clean air like a traditional 6 rotors do, 6 arm setup does. But it's like an 18%, 15 to 18% drop in efficiency, and I felt like it was worth it to have the clear view forward that it offers. And then, like I said, it offers redundancy. And the other nice thing about this, well, there's a couple other things that are nice about it. It's more, it's easier to follow the orientation of the craft. So with a 6 rotor or 6 armed or an 8 armed chassis, once you get it up in the air, you're pretty much looking at it from the bottom, you know, like this. And if you rotate it around a couple of times, it's such a big circle of arms, it's easy to lose which way is forward. And you usually need to keep up with that so that you can, you know, fly it in the direction you want to fly it and everything. So with this setup, it has a pretty unique profile from below, and I can keep track of it, you know, kind of which way it's looking more easily because it's just 3 arms. And then finally, the really nice thing about this for me, because I'm always running around these little cars and stuff, is it's very compact when you're ready to travel with it. You can fold these arms back. Let's see if you can see that. So there's one folded and one out. And still, that's not all the way out. It actually goes out a little bit farther. But folded back, and then these legs fold back. And it's pretty compact, and this GPS antenna folds down. So that's nice for compactness. It means you got to be careful that you always get everything unfolded and set up properly. As far as what all the gizmos are on this thing, like I said, this is the GPS antenna. It's on a stick there to keep it sort of away from the interference of the other electronics, give it a better signal. The funky antenna on the bottom of this blue box thing right here, this is the video transmitter. So it's sending the signal, the live feed, to my screen. And this type of antenna is a little bit more advanced than the typical stick antennas that you see that come on a lot of the devices, the transmitters and everything. They typically have this type of antenna. And this antenna tends to broadcast in a 360 degree, you know, total coverage, but it makes it a little bit weaker. This type of antenna, it's called a circular polarized antenna. It tends to direct more of the signal into a specific location. In this case, it's pointed downward, so, you know, it sends more of the signal down instead of spreading it all above the craft and everywhere that I probably won't be. The other piece of kit on here is this little transmitter and antenna here. This sends telemetry to a ground station, they call it. It can be your laptop or it can be the cell phone. And I have the cell phone telemetry set up here. So what that does is it sends data down about the status of the craft, the location.
-2 meters.
And it'll
95%.
vocally let you know what's going on. You can turn that on and off and up and down and all that, but it's kind of nice when you've got your eyes in the sky for this thing to let you know what your battery percentage is, what your height is, which is also displayed on that screen anyway, but and then the location of, I don't know if it's showing that there. So it's showing you some statistics on there, and it uses the Google Maps to show you the location of where it's at. And you can also use this to program that autonomous flight that I was talking about earlier. So what that does, the autonomous flight, you can actually use that software to put in waypoints on a map and then upload it to the aircraft, the drone, and then say, you know, lift off and say go, and it'll fly from one point to the other and come back and land or whatever you want it to do. It can stay there as long as you want. I honestly haven't used it that much. I'm still just flying by hand, but it's pretty handy if you're trying to film and, you know, fly at the same time, not to have to worry about the flying part. You can just control the camera and all that. I think that's about it. This tray here that I've got, you know, this is a little over the top, I guess, but for sort of a gentler, smoother video, it's nicer to use your fingertips, I don't know if you can see that, and pinch the sticks, as opposed to the typical laying your thumbs up there, and your thumbs tend to be a little twitchier. If you use both fingers, you tend to be a little smoother. So when you're doing video, to keep it from being too nauseating and twitchy, you know, this allows you to get a little more finesse in your inputs. And you can also use a better controller to sort of tone down your inputs through the settings in the controller. It has like exponential values, so basically as you move the controller off center 10%, it only sends 5% of the signal, basically. Well, no, I wouldn't say signal, but how much the aircraft should move. You know, you can turn that up and down, but it'll still catch up at the end. If you move the stick all the way to the end at 100%, it'll catch back up and it'll still move the craft at the full 100% range. You don't lose that range. And it also has dual rate where you can actually cut the range down, but it allows you to be a little smoother with your inputs. And I think that covers about all of it. You know, it has GPS lock, it has return to home, it has all kinds of modes. Basically, you can program in 3 or 4 modes onto these switches on the controller here from a computer and switch between those modes, but there's more than you can put on the controller. There's about 10 or 12 different flight modes you can pick from. Some really simplified ones that keep it moving in the direction you move the stick in, regardless of which way it's oriented. That was on the previous quad, it would do that I had. This one will also do it, but it's a sort of a bad habit because you need to learn to keep track of the orientation of the craft so that you can, in case of an emergency or it loses a GPS lock or something like that, you can still fly it yourself. So it's best to learn how to just keep track of the orientation and learn that left is not necessarily left when it's facing you. It moves it to your right. But yeah, I think that about covers it. If you guys have any questions, you know, you can leave them in the comments. I think I'm going to do another video about how to record more smoothly, so we'll check that out later. Till next time, later y'all.